Hey, so in this video looking at we're going to be looking at quadratics. We're going to be especially focusing on the vertex form. So our parabola or quadratic function has a parent function which is y is equal to x squared, and I've graphed that out here. And our parent function, I've taken a few points here, which would be 1 would be 1, negative 1 squared is 1, 0 squared is 0. Negative 2 squared is 4, 1 squared is 1, 2 squared is 4, 3 squared is 9. And I've plotted my 0, 0, my 1, 1, my 2 and 4, my negative 1 and 1, and my negative 2 and 4. Now we're going to be looking at the vertex form, which is another way of representing our quadratic function. So vertex form is as the name suggests, helps us give our vertex. So our Q uh, gives us our y coordinate for our vertex. Our h gives us our x coordinate for our vertex. And our y coordinate is also our translation of our graph from y is equal to x squared into moving up or down. So it's a translation from y is equal to x squared to this, up or down. And our x would be right to left, or movement. This would be movement along our y-axis. So we'll be moving along our x-axis from our y is equal to x squared, which is our parent function. Our a value stretches our function. Our a value stretches our function, vertically stretches our function to be either compressed, expanded, or more spread out and wider, or to be turned completely and be in negative form. Let me just draw that a little better. There we go. That is when a is lesser than 1 and between 0 and 1 we would have a nice wide function. When our function is greater than 1, we have a much narrower function. Narrower graph, sorry about that. Okay, so how do we find our vertex? So let's say we have a function y is equal to 2x minus 2 squared plus 4. What helps us find our vertex is, of course, this gives a y coordinate and this gives us our x coordinate. So immediately I know my y coordinate is 4, so I'm going to write that down. And the coordinate is a little more tricky because our function represents by a times x minus h squared plus q. That is our vertex form. And you see that our h always has the negative with it. It's a negative h. As a result, for our function to keep the property of being x minus 2, we would have to do negative, which we get from here, and positive 2, which means that our x is positive 2. So our vertex is positive 2. You can also think of it as just the opposite. So the opposite of negative 2 would be 2. So you just flip the signs and you get your vertex. Now that we have our bases covered, let's look at an example. So my example I have is y is equal to 2x plus 1 squared minus 3. So pause the video and then you can try to find the vertex yourself. I'm just going to give you just to pause it. Okay, so our vertex for this function, we know that our y coordinate would be negative 3, which does not change. And our x coordinate, we flip our sign of our h, which gives us negative 1. So our vertex is negative 3. And let me just plot that point. Okay, perfect. So now if I'm asked to graph this function y is equal to 2 times x plus 1 squared minus 3, and also show my transformations from my parent function, which is y is equal to x squared. So of course I know my vertex is -1, -3, which would be right here. Wait a minute. Okay, so now essentially how we use our transformations is we know that our q coordinate moves our graph up or down, our point from our parent function up or down. Our h moves our point or our coordinate from right to left, which is along our x-axis. Okay, so let me just rewrite this. Y is equal to, so our parent function we know is y is equal to x squared, which I've already graphed here using our table of values. And let's say from our parent function, I'm taking the point -1 and 1 to help me graph my function. So let me place that point -1 and 1, which would be right here. Now if I want to move this function or transform this function to represent a point on this graph, I would have to move my point 1 to the left and 3 down. So I move my point 1 to my left, which brings it here. And when I move my point 3 down, I get 1, 2, 3. I get to y is equal to -2. Now let me just erase these points. And now let me take another point. Let's say I take my point 0 and 0, 0 and 0, and this would give me my vertex directly using my transformations. So if I'm moving 1 to my left, that would give me my x coordinate of -1. If I'm moving 3 down, that would give me my y coordinate of -3, which is also my vertex. Now let's take point 1 and 1. So 1 and 1, that's our point parent function. If I have to represent it to our function given here, or transform it rather, uh, it moves from point 1 and 1 to going 1 to the left, which would be -1, which gives me 0, or rather here, 1 to the left. And that function also goes 3 down, that point, sorry, that coordinate also goes 3 down. So the y coordinate here goes 3 down, so 1 minus 3 gives me -2. So I can also put it here, so 1, 2, 3. So that's a -2 as well. Now we have 3 points, so we can gladly graph it. So that's something like what our graph would look like. And, and we can also see that our graph is a lot narrower than our parent function, and that's because our a in this case is greater than 1, because our a is 2. And as I said, if when your a is greater than 1, it's going to be narrow. When a is between 0 and 1, a, our graph is going to be wider. So that's when our a is suppose is equal to a half. And when our a is negative, when a is lesser than 1, which would be negative, let's say our graph is -2 in this case, our graph would be flipped, our vertex right here, so it would be flipped on the x-axis. So that was a vertex form for you guys.